Hello everyone. This video describes the pros and cons of using hydrogen as fuel in public transportation. The title is Hydrogen a Hot Key in Renewable Energy. My name is Saul Hugo Morales. Why has hydrogen become a hot topic? Because it's abundant in nature and it's environmentally clean. Therefore, it could become an ideal candidate for replacing diesel and gasoline in the powering of motorized vehicles. This cartoon shows another advantage of hydrogen, which is its high energetic density. In fact, the energetic density of hydrogen is 2.6 greater than the energetic density of diesel. To produce the same energy, 1 kilogram of hydrogen is equivalent to 0.82 gallons of diesel. This means that if a diesel truck travels a distance of 10 kilometers per gallon, then a hydrogen truck will travel 8.2 kilometers per kilogram. This cartoon intends to show that because hydrogen has very low density, vehicles would need huge tanks to store the necessary volumes to travel typical refueling distances. Housing this large volume is a tricky business for small and medium-sized cars. To overcome this obstacle, the volume of hydrogen can be reduced as follows: pressurizing it to 350 bar or 700 bar, liquefying it at its melting temperature of minus 253 degrees Celsius, or else storing hydrogen in a solid state, as it will be explained next. Hydrogen in a solid medium. Currently, there exists much interest in the research of hydrides, solely because hydrides can capture hydrogen ions to store them in a solid medium. This process minimizes the storage volume of hydrogen. Hydrogen in a solid medium results from absorbing hydrogen ions by nanoparticles of magnesium, hydride, or other metallic structures like aluminum. When this happens, hydrides compact and decrease the volume of hydrogen. The figure shows a nanoparticle where the hydrogen ions are gray in color. This graph shows the volumes required to travel a distance of 725 kilometers with these fuels: hydrogen solid, hydrogen liquid, hydrogen pressurized to 700 bar, and hydrogen pressurized to 350 bar. The energy in all four cases is equal to 1.26 megawatt hour. Notice in this graph that the volume of hydrogen at 350 bar is 3.3 times greater than the volume of solid hydrogen. This table shows the color codes for hydrogen. For instance, green results from extracting hydrogen with electricity generated by solar or wind energy. Blue hydrogen is a hydrogen extracted from natural gas, storing the carbonates underground. Gray hydrogen is also a natural gas-based hydrogen, but the carbonates are released into the environment. Black and brown hydrogens are produced from coal or lignite. These hydrogens are the most environmentally damaging. Pink and yellow hydrogens are generated through electrolysis powered by nuclear or solar energy, respectively. How hydrogen is produced. There are several ways to produce hydrogen. The most common ones are production of hydrogen from natural gas and production of hydrogen from electrolysis of water. Hydrogen from natural gas. The extraction of hydrogen from natural gas consists in detaching hydrogen from carbon dioxide by heating natural gas with a steam and a catalyst. This process produces blue and gray hydrogens. As shown in the figure, the production of blue hydrogen consists in storing hydrogen in large storage tanks while carbonates are re-injected underground. It is called blue as occasionally contaminants could escape up into the surface. Unfortunately, 99% of the carbonates coming from natural gas hydrogen are gray because carbonates are released into the environment. Electrolysis process. As shown in the figure, the electrolysis process is very simple. It consists of using an electric current to split water into hydrogen and oxygen. If the electrical energy comes from wind turbines or solar panels, then the gas is classified as green hydrogen. Currently, this process is not commonly used because hydrogen produced from natural gas is more economical. However, to make an impact in the decarbonization efforts, it is important to make electrolysis the dominant source of hydrogen production. This graph shows that out of 70 million tons of hydrogen produced globally in year 2021, only 4% was green. This means that 96% of the carbonates from production of hydrogen were released into the environment. How is hydrogen transported? Hydrogen is transported from production to distribution places by means of pipelines that transport hydrogen in a gaseous state, or cryogenic tanker trailers that transport hydrogen in a liquid state, or else in tube tanker trailers that carry hydrogen in a pressurized state. How is hydrogen dispensed? At the production points, equipment is deployed to vaporize and gasify liquid hydrogen to store them at pressures of 350 bar or 700 bar. Pumping stations distribute hydrogen at rates reaching a maximum of 10 kilograms per minute. Pilot projects. There are currently several projects troubleshooting the use of hydrogen in a variety of public transportation systems. The following slides show two examples. The first one refers to sea transportation. The passenger ship New Orbis is a pilot project that will travel from Amsterdam to the North Sea. This vessel will use the hydrogen retained in a solid medium called sodium boron hydride. Construction of New Orbis began in year 2020 and it will enter service in year 2024. This project is subsidized by countries of the European Union. This second example refers to land transportation. The state of California has contracted with South Korea's Hyundai company to experiment the use of hydrogen in heavy transportation in Northern California. During the first quarter of year 2023, Hyundai began operating 30 trucks with a carrying capacity of 85,000 pounds each. Their engines are powered by electricity generated by hydrogen, oxygen, and water. The internal tanks can store up to 40 kilograms of pressurized hydrogen at 350 bar. Refueling distances range from 400 to 500 miles. The average efficiency of hydrogen is 12 miles per kilogram. Pros of using hydrogen. Hydrogen exists in abundance in nature. It is present in air, water, and natural gas. If produced from renewable sources, it can help reduce carbon emissions. And, as already proven in numerous field tests, hydrogen could become an endless source of energy. Cons. One significant challenge is finding ways to decrease the transportation volume of hydrogen. Currently, most hydrogen production methods are still contaminating the environment. Large investments are required to build distribution stations like the ones used for gasoline and diesel. And hydrogen inside fuel cells is very flammable. What to expect? If hydrogen produced by renewable sources could satisfy the transportation demands, then it will provide some relief in the overwhelming task of complying with the terms of the Paris Agreement of reducing by year 2030 55% the emissions of carbon dioxide and eliminating them by year 2050. But if not, the industry will do what it has always done: rise to the challenge. Conclusions. Hydrogen as a fuel is still in its infancy. It will take a long time and a lot of money to become publicly used. Clean hydrogen used as a fuel is a viable alternative to reduce environmental pollution from cars. More attention should be placed to the storage of hydrogen in compacted and efficient ways. And production of green hydrogen should be largely enhanced. This concludes this video. Thanks for your attention. I would greatly appreciate your advice and comments.